All right, so the next few definitions on your page are all dealing with specific angles. And I actually think I'm going to start with the second definition first. So if I draw an angle in standard position, that means if you're putting it on the XY plane, the vertex is at the origin. The initial side is the positive x-axis, and then it spins from there. So no matter where my angle ends, let's say if it ends over here, this would be my angle. That's an angle in standard position. I could have angle like this. That's standard position. So the vertex is at the origin, x-axis is your initial side. It can spin, and remember we said this was the positive direction. It could also spin the negative direction. So the direction it's spinning doesn't matter. Coterminal angles are angles that end in the same position. So I could draw a lot of different angles that ended at the same spot. Let's say if I looked at this angle right here. Okay, I could just talk about that. And that would be about like a 45-degree angle. Would we agree? Or I could draw the same angle, but spinning the opposite way. When you spin clockwise, what would that measurement be? What kind of number? It's a negative number. So this is actually negative 315 degrees. Okay, if you're just looking at the degree measure, they don't look the same. But when I draw them, they turn out to be the same. Or I could even have an angle that maybe it goes like this. That means it spun all the way around. How many degrees would all the way around be? 360, and then an additional 45. So that would be like a 405-degree angle. 3 different measures, but in terms of drawing them, they all end at the same position. That's what's called a coterminal angle. And we can always, to get the actual, like figure out where to draw it, we usually just add or subtract 360. You know, if I have negative 315 and I add 360 to it, what do I get? 45. If I have 405 and I subtract 360, what do I get? 45. So you can get to the same position. We typically give our angles as a positive number between 0 and 360. And so to get that, you just add or subtract 360. Quadrantal angles are just anything where the terminal side ends on an axis. So if we're talking about standard position, this would be a quadrantal angle. What would that angle be? It's a right angle, 90 degrees. Okay, or I could have this angle, which is a straight line, or 180 degrees. Okay, or I could do this one, which would be 270. Or all the way around, that's 360. So basically multiples of 90. Sometimes those are referred to as quadrantal angles because they end on an axis. Any questions about those terms? Let's look at this one. Find the angles of least possible positive measure, coterminal with each angle. Okay, if I look at 1,106, if I told you to draw that, I have no idea where to draw that. Do you guys? No. But we can make it a more manageable number. What would I need to do? Subtract 360. All right, so when I do that, I get 746. Is that small enough? Nope, so subtract it again. You don't have to show me the work. You're welcome to do it on your calculator until you get the number you need. So I get 386. Is that small enough? No, so you subtract 360 again, and we get 26 degrees. In terms of drawing it, I didn't ask you to, but if I did, 26 degrees would be about right here. 1,106, how many times did that go all the way around? 3 times. So it went like around 1, 2, 3, and back up. So you might see a picture drawn like that sometimes. Usually if I draw a graph, I only do the coterminal angle. So I usually just do straight 26 degrees. But. All right, on B, what would I need to do? And we get? Okay, if I ask for a graph, 210, that's 90, 180, so it'd be over here. So you could draw the 210 or the negative 150 was right here. If I asked you to draw one, I wouldn't care if you drew the original or the coterminal. They end at the same point. All right, everybody do the last one. Do C on your own. Tell me what you get. Do we have an answer? We have to add 360 twice, then what'd you get? 117 degrees. All right, do we understand how to find coterminal angles? The last examples I want to do are some conversion problems. You might have done some of this like in a science class before. We will do trig or conversions throughout trig. They just pop up periodically, so we're just going to throw in a couple here to start, and we'll do more later on. So a wheel makes 270 revolutions per minute. Through how many degrees will a point on the edge of the wheel move in 5 seconds? So some people, their minds just work. They can look at that, push some buttons on their calculator, and give me an answer. Okay, if that's you, just make sure you can write down what you did on your calculator to get that answer. The rest of us, we need to see more. We can't just look at this and automatically know, oh, I should multiply by this and divide by this. Okay? What I like to do is just set it up as a fraction. 270 revolutions per minute. So 270, I include my labels. Revolutions, per is like dividing a minute. Okay, I need to get 2 degrees. So first I have to figure out how do I go from a revolution to a degree. What does a revolution mean? It went 1 time around. How many degrees is 1 time around? Okay, so I know 1 revolution is the same thing as 360 degrees. Let's set it up so everything will cancel out. Okay, I have revolutions on top. If I want those to go away, I need top and bottom to cancel. Right? And I'm going to turn it into degrees. So I said 1 revolution is equal to 360 degrees. It's just like multiplying by 1 right there, because the 360 degrees, the 1 revolution are equal. But what happens now, those revolutions cancel out. So I'm now in degrees per minute. But I want to know how far it moves in 5 seconds. So how do I go from minutes to seconds? So one way to think about it, you want minutes to cancel. Since it's on the bottom here, it'd have to go on the top here. Seconds, we know 1 minute is 60 seconds. So you might have just said, I know I'd have to divide by 60, or you might like to write it out so you have that visual. And then how long are we spinning?
5 seconds.
5 seconds. So all we have to do is at the end multiply by 5 seconds. So then my seconds cancel. So you notice, what's the only unit left? Degrees. So I'm going to get my answer in degrees. So I have to do 270 times 360 divided by 60 and times 5. You can type all of that in. You're just multiplying the top, dividing by the bottom. We get 8,100 degrees. Okay. Basically anything on the top. So I did 270 times 360 times 1 times 5. And then I divided by the bottom. So divided by 6. Did you guys get that? I am not a person that expects you to work every problem like me, so if you can do this differently, that's okay. I'm fine with that. Just make sure you're showing me enough work that I know how you got your answer. But I think, in general, this method is nice because you can see units cancel out, and so you can make sure you're on the right track. Why don't you guys try the next one? See if you can set that up. So, 480 revolutions per minute. I need degrees, so if I want to get rid of revolutions, it's on top, so it needs to go on the bottom, changing it to degrees. We know 360 degrees is equal to 1 revolution. I need to move to seconds, so I need my minutes to cancel out. So I need to put them on top. I need seconds. 1 minute is 60 seconds. And it's spinning for 2 seconds, so times 2 seconds. So you do 480 times 360 times 2 and divide by 60. So you should get 5,760 degrees. And it looked like we did pretty well with that one. So I'm going to stop for a little bit and give you guys time to work on homework. And then towards the end of the class, I may stop and do some examples from the next section. Part of this in our notes today, and it is the special angle relationships. This is a huge component of geometry, so if you've taken geometry or you are in geometry, it's probably really familiar to you. If you're not, or you haven't had geometry, it's not a big deal. I'm covering this. I'm not ever going to require you to tell me the names of these things, but it's something that can be helpful to us later on when we're solving problems. If we remember these, it could save us a little time on some of the problems. So what I want is to look at the scenario where you have 2 parallel lines cut by a transversal. All right, so I have all these angles. I'm just going to number them. Okay, I don't really care about the names of these. What I most care about is if I gave you a picture and we had something come up, can we find the angle measures? We can go through some of the names. Alternate, what does alternate mean? Opposite sides. Interior, so that means they are inside the parallel lines on opposite sides. So that would be angle 3 and angle what? 6. The other set would be angle 4 and 5. Alternate, because they're on opposite sides in between parallel lines. The important thing here, what's true about those measures?
They have the same degree.
Yes, they are equal in the same degree, or you could say congruent. I don't care if you use the right term, if you say equal, I don't care, that's fine, but they are the same measurement. All right, alternate exteriors. So alternate is still opposite sides, exterior means they are outside. So that would be 1 and 8. The other would be 2 and 7. Okay, if these interior angles are equal, what's going to be true about the outside ones? They are also equal or congruent. All right. The next one. Does he call them consecutive interior or same side interior? Both. Okay, it can be either way, consecutive, same side, just means they're in a row, in between those parallel lines. So that would be like angle 3 and angle 5. Okay, they're on the same side of that transversal. What would be the other set? Okay. We already know that 3 is equal to 6. So what would have to be true about 3 and 5? Supplementary, they make a straight line. All right. Corresponding. Corresponding just means the same position. So for instance, angle 1. It's above the parallel line to the left of the transversal. What's the other angle that's above a parallel line and to the left of a transversal? 5. So 1 and 5. 2 and 6. 3 is to the left and below, so to the left and below would be 7. And the last one, 4 and 8. And what's true about those measurements? They are congruent. Okay, last one's vertical angles. Those like make an X with each other. They're across from each other in that X. So angle 1, what's across from it? 4. Okay. Angle 2 and angle 3. 5 and 8. And the last one, 6 and 7. And what's true about those?